The next topic is actually related to science for education and education for science. Igor Balaz was involved in this subject, and he will give us some small overview of activities during the last 2 years.
Okay, after you heard the work of PhD students, we should take a look, a step back, and to see how, because PhD students are not yet formally scientists, but they are already mostly well trained how science should be performed. And in our activities, which we entitled Science for Education and Education for Science, we actually wanted to see how, on one hand, science is taught in schools, and how you can engage with kids and pupils to be interested in science. But on the other hand, we also wanted to see whether current school system is suitable enough to train future scientists, and what is necessary to actually train future scientists. The whole work was part of the work package 3, dissemination and exploitation, and in the project proposal, it was in the project description, it was defined as bring research into schools. And this is the sentence from the project description. The idea was to raise the level of interest in research and higher education in younger generation. During our work, during this last 2 years, we actually expanded a bit our scope, so it was not only to raise the level of interest, but to try to discuss with them how they perceive science and what is their impression of it. As a part of this work package, we organized two large group of activities. One is so-called Children's University. I said so-called because a real Children's University is Europe-wide organization with a lot of participants. One of them is BOKU, actually. And what we tried to do here is informal look-alike Children's University on a very small scale. And the other group of activities were round tables, and I will talk about them a bit later. So we organized these Children's Universities for 2 consecutive years. In total, we made 4 events, and at each year we divided kids into 2 groups: younger kids, 8 to 9 years old, and a bit older kids, 9 to 10 years old. In each case, we discussed with them and we presented them some environmental related topics. We combined that topic with some experimental, practical work, not real experimental. And at each event, we also tried to discuss with them what is science, how they perceive science, and what actually is science, and what are the differences between these 2 ideas. I will present just 2 of these events. I think this picture are from the 3rd event, I'm not so sure. So anyway, we discussed at this event global climate change, increase of average temperature on Earth, and together with them try to simulate melting glaciers with modeling clay, ice, and water. As you can see, they were pretty active during the introductory lecture, and the idea was quite simple. All of these kids were divided into groups of 2, and each group had 2 boxes and a bunch of model and clay. And in each box they modeled land mass and put water into them. And in one scenario they put ice only in the water, and in another scenario they put ice only at the land. And the question for them was what would happen when the ice melted down. And I was quite happy by the fact that all of them were wrong in their predictions. I will explain why I was happy. Okay, they uniformly expected that level of water will rise in both scenarios. They were a bit different in which box there will be more water, but it was a great opportunity actually to show them that common sense does not mean very much in science. That you should perform experiments and test your ideas. You cannot just go around and shout your ideas, and they cannot be perceived as proven, even if they are in accordance to our common sense. And since this was with quite young kids, I guess it was quite eye-opening for them to see a real-world example where their idea that, yes, of course it will happen, actually did not happen. So yeah, that was the goal. And yeah, some of the kids were quite eager to make notes and all measurements correct. So yeah, they were quite nice. And in another experiment, we discussed about erosion, and experiment was quite simple. We take some blackboard chalk and vinegar and water, and yeah, here's the procedure, and here, and here. And at the beginning, of course, they put one chalk in the water, the other one in the vinegar, and after, I think, about half an hour of my talk, they removed them, and I guess, let me see, yeah, the difference is visible. So they had the opportunity to see on a very small time scale quite visible difference between this watery environment and quite acidic environment, and what it can do to carbonate. Yeah, and they continued mostly their activities by dissolving chalks into powder. So it was quite, they were quite happy with that continued activities. Yeah, another thing we tried to emphasize with these kids were to try to discuss with them some basics of scientific method and scientific practice. And in schools, yeah, they mostly heard about scientific practice, usually have experiments, because the teaching material is organized like that. Some very smart guy performed some experiments, he got some astonishing results, and now you are obliged to learn it. But there are other issues I think are also equally important in teaching kids what is science, because especially now when they can access a huge amount of information via internet or whatever, they can be quite easily confused. At first, what is pseudoscience and what is science? Because pseudoscience is usually represented as a science, but it is not. And we try to emphasize a difference between these two, how you can make an at least educated guess what kind of validity you should attach to some claims. We also discussed proto-science versus science, and I want to make clear to them that scientific knowledge is always temporary. You do not have some eternal scientific truths. Some are more resilient, some are less, but in general, our scientific knowledge depends on our general knowledge of the world around us, and it is changeable. And I think that kids should be quite aware of that because they were taught in schools in general, not only here. As my experience is, it's almost worldwide phenomenon. You teach science for kids as unchangeable facts. We have gravitation, we have Earth is round, or whatever. And they were not, and after learning these facts, they were, of course, forced to repeat them, and they are graded in accordance to their memorization of these facts. There are no points where they were taught how scientific knowledge was changing, what was the dynamic of change of scientific knowledge. And especially now it is important. I guess a few centuries ago it was not so important because you can happily live your whole life without anything changing in science around you. But now scientific progress is accelerating, and a lot of things we thought we know a few decades ago are not relevant anymore. And if in school kids are not taught that yes, this knowledge can be changed and it is still science, my impression is that you can undermine their ability to judge science correctly, because maybe it is too strong to say, but my impression is that science is usually taught in a manner of religion. You have these facts and you should learn them, and there is no discussion about them. But this is not a science. As you all know, you especially if you're at the frontier of science, you always need to challenge existing facts. You always need to make a step further. So that's why we try to emphasize that yes, knowledge is temporary. And last point here, that all scientific knowledge should be falsifiable. In other words, if you claim something that cannot be refuted, it is not science. And every scientific claim should be refutable, at least in principle. And we tried to, maybe these concepts sound, I guess, advanced for these kids, but yeah, my impression was that we made a nice job, at least making this story interesting, and they had a lot of questions about some of these issues. Yeah. So similar thing as this with kids, we try to organize with younger students, with high school students, and here at the faculty with I think there were postdocs or postdocs. Docs. Okay, with docs. And it was even more interesting than this with kids. So first, idea was to organize a round table about critical thinking. And as you can see on these bullet points, these were our main targets. What is critical thinking? Why it can be actually useful? Does, and if yes or no, formal education in schools nurture critical thinking? And we also emphasize some of the main aspects of critical thinking, like openness to new ideas, willingness to accept argument and to change your mind if arguments are valid. And we tried to discuss to what extent these characteristics can be useful not only in science but in real everyday life, in school, in politics, or whatever. And our initial idea was to organize these roundtables in three gymnasiums or prep schools, whatever you want to call them, three top ones in Novi Sad, and these were the responses from two of them. And at first I was quite amazed, and I didn't know what to think about it. After some initial shock, I tried to go over it. Sorry.
Digest.
To digest it, because when I was first these were the sentences from psychologists from these schools, two of the schools bluntly rejects us, and we somehow managed to organize a roundtable in one of these initial schools, not initial, from these schools we initially thought about. After that, I also made a contact with one private prep school in Novi Sad, and so we ended with two roundtables, one with private prep school and one with public prep school. And it took 120 days to organize the event with the public prep school. It only took me 3 days to organize the same event with private prep school. And that was amazing for me. I don't know why it took almost 3 months to organize it. After initial email, I was waiting for some time, and then I sent another email. And after some waiting, I sent a third email. And then I got some response, and then Branislava helped to accelerate that communication. But at the end, it took us 3 months. With this private prep school, we made an initial discussion, quite short. After a few days, we arranged a date, place, and everything. So it was very rapid. Anyway, in each case, we organized these events. Duration time was quite longer than we projected, and I was quite happy about that, because it showed us that this kind of discussion is obviously something which is needed for these kids. These are my some thoughts about that. I can skip this. We opened a lot of questions, and I was at some points I was puzzled by their responses. I will go to responses at the concluding section, but I think that on the one hand we learned a lot. First about the school system here, and then about the kids and how they think, and hopefully they also learn something, because they had a bunch of questions And it was interesting that those questions, in some cases, they were quite focused on the topic, but in most of the cases, they were all around the place, just tangentially connected to the critical thinking. But there was a huge amount of topics they wanted to discuss related to science in general, but about their belief whether, I don't know, vaccines can cause autism to climate change. So yeah, it was a quite challenging event. So we organized also one roundtable here at the Faculty of Agriculture, and as you can see, it was at some points we got some fierce debates here, and it was with we organized it with help with Professor Dusan Petric. He's not here. Yeah,
he will join us.
He will join us. Yeah. Okay. Okay. These are some pictures from this event. So for my first impression was, yeah, that it became almost deadly to try to open some questions in public schools here. In all cases, with these roundtables, kids are aware of the problem, and problems are that yes, they are taught in quite dogmatic way about the facts. They do not have opportunity to discuss with their teachers anything, mostly. And their response is usually very pragmatic, and that's okay. By that I mean that they realize that there is a problem, but since there is no solution for that, okay, that's life. And they just go further. But as a consequence, they obviously lack any skills of critical thinking. Main indicator for that is amount of conspiracy theories they believe. That's huge. From vaccines to climate change denialism to, I don't know, some shadowy organizations that rule everything. So yeah, that was quite revealing to them, to me actually. To realize to what extent they cannot critically think about the world around them. Well, yeah, I guess it should be obvious because they were not trained in that. But anyway, I was perplexed at some points. Also, one typical thing for them is that usually they try to find some justifications for their teachers. Okay, they have small salaries, they do not have enough time, and so on. So, yeah, they are, I guess, quite empathic, but on the other hand, it also does not give them opportunity to say or to demand anything from inside what should be changed. They start the school, they know very early, they learn how the system works, probably also the older students teach them, and they just get the idea, okay, I will go to school and go further to university or whatever, without any ambition to change anything. And yeah, as I already emphasized, there was a huge difference between public and private school in the manner of response time. Students in both schools, their way of thinking was quite the same, pretty much the same, but at least on this very small example, in private schools, we got more more eager teachers to at least do something. I guess, well, it is not enough, but at least it is something. Yeah, thanks.